Okay, can see my slides, right?
Yeah.
Have I shown you this already? I think I did, is it? Last week.
I don't think so.
Okay, actually, these are what you need to know for this topic in Sec 2. Okay, so SI unit of temperature is Kelvin, capital K, but in Singapore, we use degrees Celsius. Yeah, so even though SI unit is this, okay, not all countries uses that. Some countries use Fahrenheit. Okay, but then for Singapore, it's degrees Celsius. So you need to describe some of the effects and applications of expansion and contraction in everyday life. Also need to explain transfer of heat energy through conduction, convection, and radiation. So as you actually go through, I have not given you these notes, right?
No.
So I will send later at the end of class. I will quickly convert to PDF and send it to both of you. Hi, Sherman. Hi, Sherman.
Hi.
Hi. Okay, you're very soft. Okay, but that's fine. Okay, Sherman, I was just going through with Jocelyn. These are the key concepts you all need to know. Yep, and then we just covered the part on temperature, which is Kelvin, and then we did talk about, even though the SI unit is actually capital K, right? But in different countries, they use different unit. In Singapore, we use degrees Celsius. Okay, some countries use Fahrenheit. Some countries can go for Kelvin. Now, describe some of the effects and application of expansion and contraction. When you're doing revision, both of you, okay, because I'm giving you these slides, okay, you are supposed to look through all this. Once you know this part, put a tick, okay? Then ask yourself, hey, can I actually describe effects and applications of expansion and contraction? If yes, okay, good. Okay, if no, then you go and read up a bit more. Okay, explain transfer of heat energy through the different ways, conduction, convection, radiation. If you can explain for all of them, you think this way. This is how you should be testing yourself or checking whether you have studied enough and you're ready for exam. Then show an understanding that the rate of heat loss, okay, or gain by a body through radiation, okay, now we're talking about radiation, is actually affected by color and texture as well as surface temperature. Okay, and then explain applications of transfer of heat energy through conduction, convection. Okay, and then applications of transfer of heat energy through radiation. Okay, so all these you need to know. Then infer that generally solid liquid gases expand when heat is absorbed and contract when heat energy is given out. Okay, so all these you can already give explanation, describe a little bit, you should be fine. Thermal expansion results in the change of volume, therefore density of the substance also changes. All right, so we talk about the convection. Remember, in liquid, in gas, yeah, so when there is heat, okay, the liquid starts to expand. Okay, so when it expands, the volume increase. Volume increase, density will drop. So when the density becomes lower, it will start to float. Yeah, so it rises upwards. Then infer from experiment that different materials have different rates of heat energy transfer. Okay. Then very quickly, I think we have gone through this before, right? Okay, I just moved through very quickly for this lesson. Your expansion, contraction. So you talk about increase in size or decrease in size when temperature changes. Okay, so note down whether it's during heating or during cooling. Now, the steel MRT tracks have small gaps to allow for expansion. This is also the same for the bridges, okay? So for bridges, they are made of, okay, some bridges are made of metal. Okay, some bridges, you have concrete ground. But no matter what, there are always small gaps. Okay, there are always small gaps to allow for expansion during hot weather. Yeah, so You might not always have things like rollers to allow for movement, but you always see these expansion gaps. There are always gaps to allow for expansion. Bimetallic strip, you know already, bimetallic strip, they will bend, okay? And then they, according to how they bend, they are put into different uses. Okay, so for the even, let's say it is the aircon unit, okay, the bimetallic strip will bend accordingly. How it bends, you must understand the use of it, what is expected, all right, what's the requirement. Conduction, transfer of heat through a material, okay. I think other definition, yeah, you will see, okay. Let me just quickly turn to the textbook. Hold on. Okay. If you have your textbook with you, it's good to have your textbook beside you when we are having our class. Okay, this is the exact one in your book. Okay, but later I show you a video for you to understand conduction better. All right. Where's my mouse? Okay. Now, so you talk about conductors, poor conductors, good conductors. Now, poor conductors, we also call them insulators. Okay. Insulators, right? So they are like liquids, gases, some solids. Yeah, but in general, okay, solids are good conductors, especially metals. Okay, so we talk about the iron, we talk about the oven gloves, okay, like even your jackets, the winter jackets. Why they keep you warm? Why blankets also keep you warm? Because air is being trapped. Okay, same logic here. Air is being trapped. Air is a poor conductor of heat. That's why we can be kept warm. Now here, okay, convection, transfer of heat from one place to another by the movement of the medium itself. So you can see that it is actually the liquid over here that is heated. It carries this heat energy upwards. So that the heated water moves. Yeah. Okay. So when water is heated, water molecules move faster and then spread further apart. The volume of water increases, causing the density to decrease. So the hot and less dense water rises, cooler, denser water sinks. So when the cooler water comes downwards, right, it will actually go to where the heat source is. It will get heated and then it rises up and the pattern repeats until the water is thoroughly heated. So there's this convection current which transfers heat around the beaker. Now we also saw this particular chimney with the gas. We saw the video in the other lesson. Okay, so actually when you have a candle placed here, the heat from the candle causes the air around it to be heated, and then the hot air rises because it expands and becomes less dense. When the hot air rises, okay, there are actually air leaving this box. So the cold air must then come in to take its place. Cold air will then come in. Okay, the cold air that goes in again gets heated by the candle, becomes hot, expands, and rises. So the process repeats. Okay, radiation, we talk about radiation being the transfer of heat without any medium. Okay, so it can occur in solid, liquid, gas. Objects that are warmer than their surrounding will then give out heat as radiation. All of us, we are always hotter than our surroundings because our body temperature is about 36, 37, right? Degrees Celsius. Okay, the usual room temperature, I'm not talking about under the hot sun, but inside your house. Okay, so long as you're in a sheltered place, the temperature is usually, okay, around 20 something. So we are always giving out heat. Okay, now, so if you look at the appearance of the surface, okay, Talking about absorber, that means taking in the heat, right? Absorbing the heat. Black and dull surfaces absorb more heat compared to white and shiny surfaces. Yeah. And then if the surfaces are rough, even better, right? Better absorber. If it's smooth, not as good, but it will still absorb heat. So if we talk about giving out heat, radiator means give out heat. Okay, so they give out heat, right? The better ones will be the black and the dull surface or appearance. Okay, black dull appearance and then rough surfaces. So if you talk about texture, then it has to be rough. If you talk about color, it has to be black and it must not be shiny, not the kind that is glossy, should be the very dull type. Okay, so if it's poor radiator, that means does not give out so much heat. Usually surfaces will be white, shiny, and smooth. All right, so factors that affect. Okay, so you see the temperature, I see an error in the question, okay, that you attempted. So the greater the temperature difference between body and surrounding, that means, for example, us, okay, the hotter we are than our surrounding. So if we are in an aircon room, maybe the temperature is adjusted to about 19 degrees or 20 degrees, then our body temperature is a lot higher than the surrounding. We will give out more heat. Yeah, the rate of losing heat will be higher. So we lose more heat per second. That's why you start to get cold in aircon room because you're losing heat. Okay, so application, okay, so read this application we've gone through before. All right, so now let's go on to our worksheet. Okay, but maybe just watch the video very quickly. Only 2 minutes, this video. Okay, so that's the video. Let's go on to the worksheet now. Sherman?
Yeah.
Did you do the structured question?
No. I did the rest.
You did MCQ. Maybe I'll try to do the structured questions, Ken, from now on. Okay, because I can read your answers also. So I want to try to mark your work. I want to improve the way you write your answers. Ken? Okay, Sherman, can or not?
Yeah.
Try your best. Same for Jocelyn, but Jocelyn shared with me some of the problems she faced when she's answering the structured questions, like, want to go to the next line, sometimes not possible. Then when she clicked enter to go on to next part question, instead it went to submission. Yeah, so she cannot complete her structured questions. That's what she shared with me. Yeah, so if you face the same problem, okay, then you have to let me know. Okay, so Jocelyn and Sherman, next lesson, when you are given the questions, right? Let's say you can't do the structured questions during the lesson time, you must let me know. So I can give the some information to the back-end team. Then it can improve on the system for you all to answer. Can? Okay, this one we went through already. So let's look at the questions now. In which state can heat transfer by convection occurs? Okay, convection. Convection, the particles must move, right? So only liquid and gas. I think this one is quite straightforward. Okay, so this one is liquid and gas only. Do you know that conduction can happen for solid, liquid, and gas as well? Do you know that? Thumbs up, thumbs down. If you know, you put thumbs up. If you don't know, put thumbs down. Sherman knows are good. Jocelyn, Jocelyn, are you here? Okay, good. So you know also, wonderful. Now, this diagram shows how heat from a campfire can be transferred. So which of the following is correct? You look at X. What is this? Look at Z. Okay, how does the heat actually move from this part, okay, to the other end?